Okay, today's lesson is on power, right? Power is an electrical quantity that's measured in watts. And we are going to do calculations around power. It's a three-term equation, you get it in the data book. So the three terms are power is equal to current, we already know about current, multiplied by voltage. Okay, so P equals IV, and the units are watts. So you would write the letter W after any answer that you calculate. So if you had a system that had a resistor and you knew that the voltage across that resistor was 6 volts and that the current through it was 12 amps, you could calculate the power dissipated in that resistor. So we talk about power as being dissipated, right? So P equals IV equals 12 times 6 equals, can I do that in my head? 72 watts. That's the kind of thing that we would expect to see. That would need to be rounded to one significant figure. 70 watts. So that's the type of simple calculation that we're going to do. Because of Ohm's law, there's other ways we could express power, right? So like Ohm's law tells us that I equals V over R. So that means that we could look at this equation, P equals IV, and we could replace that I with V over R, because I equals V over R. That's the same as V times V over R. That's the same as V squared over R. We could also say that Ohm's law tells us that V equals IR. So that means that we could substitute that in here. So if we've got P equals IV, we could put IR in instead of V. That's I times R. So that's the same as I squared R. So we end up with these three terms, given that this is true and this is true. The equation for power is given to us, the equation for Ohm's law is given to us. Given that those two things are true and they have the same components in them, they've both got voltage and current in them, it means that we end up with three possible terms for power. You've got IV, you've got V squared over R, and you've got I squared R. So if you know a voltage and a resistance, you can work out power. If you know a current and a resistance, you can work out power. If you know a current and a voltage, you can work out power. It also means that if you know a power and a current, you can work out voltage, because remember, you should be able to rearrange this equation. So I equals P over V, or V equals P over I. Just rearranging that guy. Same here, given that P equals, I'll start up here, P equals V squared over R, I could rearrange that for R equals V squared over P. Or, a little bit harder, V equals the square root of PR. The square root is what happens when you move the square over the other side of the equal sign. So the first step would be to put the R up, so V squared equals RP, and then move the square over, V equals the square root of RP, square root of PR in this case. And then the same down here, so we could work out what R equals, move the I squared over, it's multiplying on this side, so it will be dividing on the other side. P divided by I squared would give you R. Or we could work out the current. I equals P over R square root of. So, given our ability to rearrange equations and given the data book gives us this one. It gives us this one. It also gives us this one. And it gives us this one. All those equations are in the data book. You should be able to do calculations. So all I'm going to do is point you at a bunch of questions in the notes. In the notes you can read, so in applied electronics there's a section on power. Power is in terms of what is power. Power is like instantaneous energy. It's an instantaneous reading. Whatever the voltage and current is in that moment, you can work out the effectiveness of that device. So a 60 watt bulb tells you how bright the bulb is going to be. Sorry, the wattage of a bulb tells you how bright the bulb is going to be. It doesn't tell you about its energy over time. It doesn't tell you how it's going to respond over time. So if you compare a 40 watt bulb to a 60 watt bulb, or a 60 watt bulb to a 100 watt bulb, you know what one's going to be brighter. What one's going to affect your energy bills, for instance. Then we're looking at energy. Then we have to add in time, okay? And we'll move on to energy after we're finished electronics. But power is like energy in the moment, right? And its units are watts. It tells you how effective something is. You'll be confident in using the word powerful, how powerful something is. It's a powerful torch. You might not use it or a powerful motor. You might not use it in terms of like, is this a powerful heating element or whatever, but it means the same thing. How powerful is the thing? How effective is it? So that's what power is, and that's how we calculate it. We calculate it by either multiplying the current and the voltage together, or by dividing the voltage squared by the resistance of the device, or by multiplying the square of the current by the resistance of the device. So that's what power is. That's how we calculate it. I've given you the different forms of it in the video, so you can come back and look at that again. And somewhere in here we've got power questions. I think I may have went by them. Let's go back. Here we are. Right, so power and electric circuits. There's the equation there, and again you can refer to the data book for that stuff. Read through these examples, copy down the worked examples, and then you've got questions on power. And you can see how simple it is. So this first one is the power consumption of the motor. You know the current through it, 3 amps. You know the voltage across it, 200. So you've got I, you've got V. You can work out the current through it. You also know Kirchhoff's law. So when it says the voltage of the lamp, if there's 240 volts from here to here, and there's 200 from there to there, that must mean there's 40 from there to there. So you know there's 40 volts across it, and you can see that it's a series circuit. So you know it's 3 amps through the bulb. And then when you come to do the last part, total power drawn from supply, just use the supply voltage and the supply current to work out the power in the supply. So the power in there would be, what's that, 4 times 320, 720 watts is what you would arrive at for the power in part C. You need to write it all down and do the questions. That's the process, okay? So I want you to, what page is this on here? It says page 46 in the PDF, the viewer, but that might not be page 76 in the notes, but oh, that's jumped the page, hold on. Yeah, so it looks like page 46 in the actual notes itself. Alright, 45 and 46. It says 46 and 47 in the viewer. Okay, nice one. This file is in the files section of the team. Thank you.